Hi. You don't know me, and let's face it, I'd rather not know you. Meet my friend Mr. Ducky. He's a graduation duck. He's a senior duck. He wants to graduate. Hopefully you will too, right? Okay guys, let's get back to this. First law of thermodynamics. We talked about the energy of the universe being constant. The law of conservation of energy. We said that Q is equal to heat, W is equal to work, and the change in energy is work plus the heat. And we only said about take the system's point of view to decide signs. Now we'll do a couple of examples, okay? But this diagram is a lifesaver. You should know this diagram. Look at the system. If work is being done in the system, then work is negative, and the energy is negative. I mean, sorry, not negative, positive. Sorry guys, positive, positive. And then here, when the work is done by the system, it's less than zero, it's negative, okay? And if heat is coming from the system, it's also negative. Just like energy going in is positive, energy going out is negative, just like we said about endothermic and exothermic. Remember, if the system's putting energy out, that's negative. And that's the same thing with the work and the heat. They're going to be negative. If the energy is going into the system, then the work and the heat are both going to be positive. Okay? Now, there is a sign convention, that's the plus minus, to reference our system. For example, the plus Q, the system gains the heat from the surrounding. The minus Q is the system loses heat to the surrounding. Think endothermic, exothermic. Plus W, the work done on the system by the surrounding, and minus W, the work done by the system on the surrounding. Again, think endothermic, exothermic. That should be a real good clue for you guys. Okay? Alright. Now, exactly what is work? I mean, some people I know of in my classes, they have an allergy to it, you know, and alright, you know, but that'll catch up to them at some point. And other people, they work very hard, okay? Like members of my former Imperial Guard, they worked pretty hard at this. Because this is not something where like, oh, I can just look at it and that's it. I already know. No, it doesn't work that way. Now you have to work at it, okay? You have to spend the time understanding the ideas, okay? So you need to understand that. So what is work? Force acting over a distance. Guess what? That's a physics spoiler alert because we do the same thing. We do force over a distance. So work is equal to force times the change in distance, okay? Now we also have to look at the idea of pressure. Pressure is force over area. A quick thing about pressure is you're creating pressure on the ground because you're sitting at a desk and the desk is on the ground. So there's four legs of the desk. They're putting pressure on the ground. There's a force over the little area, okay? When you put your feet down on the floor and it's in contact with the floor, guess what? That's pressure. Yes, absolutely, okay? So if pressure is equal to force over area, the distance is the volume over the area, which is also known as the volume divided by the area. Okay, so work is equal to pressure times area times delta volume over area, and that equals P delta V. So all this, if you didn't understand it, here's an easy way to look at this. Work is pressure times the change in volume. Because all this is showing you how the area cancels out. This is just showing you, it's a proof, okay? And the units are liter atmosphere. So it's, in other words, it's liter times atmosphere. That's the idea behind it, okay? Let's go ahead and move on. So the thing is though, work needs a sign. And I kind of did put a little joke there. Work needs a sign. That's a visual. If the volume of a gas increases, the system has done work on the surroundings. So with the volume of the gas Expands, work was done on the surroundings. Okay? So that means work is going to be negative. W is going to be negative, just like we did in the slide before, a couple of slides before. And that'd be kind of an exothermic action, right? So work is equal to negative P delta V. Expanding work is negative, okay? So contracting, surroundings do work on the system when W is positive. So if something is contracting, it's shrinking, okay? If we're looking at, oh, gosh, my friend little ducky here, and it's, okay, it's contracting. Well, what am I doing the work on? I'm doing work on Mr. Ducky. So that is positive. Mr. Ducky is my system. If I'm working on Mr. Ducky, I'm putting pressure, changing the volume. It's Mr. Ducky's being hurt. Don't you hear him crying out? Yeah, I didn't think so. All right. So that's where the work on the system is positive. Now, we also have to understand liter atmosphere is not typically a unit that scientists want to work for. Okay? But we do have a conversion. 1 liter atmosphere equals 101.3 joules. A joule is a unit of energy. A joule is how much energy does it take to raise 1 gram of water 1 degree Celsius. If that gives you an idea. Now, is it linked to calories? Oh, my Lady Gaga? Absolutely it does. Totally. Oh, yes. So, what we're going to do here is a couple of examples. This is going to really be important for you guys. In fact, I'm going to make a separate video that cover the examples here. Okay? Because that needs to be spending a little bit more time. So I want to let you're going to stop here, okay, for this video. And then what's going to happen is I'm going to go and work on those couple of examples with you guys. All right? All right. I'll catch you on the flip side.